Yes. So, okay. Thank you for this opportunity. Today I'll talk about our recent paper on string theory in 2D Young-Mills, for 2D Young-Mills theory. This work is done in collaboration with Ofer and Tal from Weizmann Institute. So, from 80s we know that 2D Young-Mills theory is exactly solvable. That means that we know the exact expressions for the partition function and for the Wilson loop expectation values for any gauge group, for example, any SUN for any 2D manifold. Now in 93, Gross and Taylor for SUN 2D Young-Mills, they did a large expansion of this partition function and the Wilson loop expectation values and organized this series as a sum over various very specific worldsheet maps. Now what we needed was a string action which will reproduce all these expansion numbers, and another point is that since very particular kind of maps contributes to this summation, one can presume that a topological string theory will localize to those specific maps and it will reproduce the expansion. So such topological string theory attempts have been made previously, first by Moore and collaborators who suggested to localize the maps to holomorphic maps, and which eventually contributes to the chiral part of the Young-Mills, and it satisfies, it matches the chiral part of the Young-Mills theory. Second proposal by Horava from 96, where he suggested to localize to extremal area maps instead of the previous one, and which is a solution to the Nambu-Goto equation, and it also includes all the non-chiral maps, and in particular it includes all the maps included in the Gross and Taylor expansion. Both of them worked at the zero Young-Mills coupling and gave a very vague proposal for the finite Tuft coupling. So we started with the Hojabaz action and at zero coupling, and we planned to add matter and do extra calculations. But we saw certain problem with the Hojabaz action. The first problem is one of the term in the action vanishes identically. That's why the modular space is ill-defined. And the first thing we did is we found a correct replacement for this action, and now it matches the zero Young-Mills case. The second thing is, while calculating the one loop correction to this localization process, we had to reformulate the theory as a Polyakov type path integral, and this is the action for that. And we saw that various ill-defined non-chiral maps got regulated through taking limit of more well-behaved maps. So finally, we are trying to add boundaries to these string worldsheets to calculate the Wilson loop expectation values, which are also known exactly for NEN. So the most important development would be to add finite coupling corrections to this theories, and note that this theory will depend on the area of the manifold, and it doesn't it will not be a topological theory. Finally, we can add matter to this theory, like fundamental or adjoint, to reproduce the Tuft spectrum, and also to go to higher dimension. Thank you.
Okay, great.
Yes.
Questions?
Yes.
Very nice talk. Have you tried generalizing this to quantum Q deformation of 2D Young-Mills?
No. Q
Okay.
deformation of 2D Young-Mills, no, I don't.
Okay.
There is also a generalized Young-Mills which we can try. Like that also, we don't know exactly how to do. Yeah. Any other question?
Okay.
Okay.
Big applause again.